Okay, for the next hour, you're gonna listen to Ilya. The only way I could be here was offering to Harold. So thank you very much that I can listen as well.
Sure.
Because the spot was still open. There's a big line waiting to get in as well. So I'm very excited.
Okay.
The floor is yours. If you've got any questions in an hour, you can ask them after Ilya's finished. So.
Great. Right. Thank you. Right. So clearly, I'm talking about hacking smartphones. Before I do that, a word or two about who I am. I'm Ilya, as Aim already said. I work for a company called IOActive, who graciously sponsored some of my phones. I'm also part of a security research group called Netric, and I have a blog that I sporadically update at best. It's been a while, but every so often I'll post something there. Right, so what exactly will I be talking about? As an introduction, I'll have some goals as to what I'm doing, what I'm not doing. Talk about entry point in smartphones and how to get there and stuff like that. I'll talk about how can you fingerprint a phone, like I got your number, I'll figure out what phone you're using. And then I'll say a word or two about exploiting bugs on smartphone. Basically, this talk is the accumulation of stuff I've learned over the last 2 or 3 months. I actually never owned a smartphone up until quite recently when my boss said, here, go play with this stuff. And so obviously they push this stuff in your hands and says, well, I wonder what I can really do with this stuff. I'll basically cover your main entry points, SMS, MMS, as well as the cell phone applications, iPhone applications, BlackBerry applications, that kind of stuff. I didn't get exactly as far as I wanted to, so there's bits and pieces missing. However, I think there's still very interesting tidbits here and there. So the slide deck could have been called, my struggle with new attack surfaces and communication protocols. But that didn't sound so sexy, so I called it hacking smartphones. So what am I not talking about? I'm not talking about any of the magic that telcos do, the baseband stuff, the SS7. I try to stay as far away from that as possible. Touching those kind of things can be touchy because you don't own the things and stuff like that, and it might upset people. So I'm not talking about any of those things. What am I talking about? The phones, and only the phones, really. I mean, you use the cell phone network to send your stuff through, but I'm not playing with the cell phone networks themselves. Only the phones. Basically, I'm talking about I send stuff from my phone, ends up at your phone. What can I do with that? And specifically, only attacking the application CPU, not the baseband CPU. When you look at entry points for smartphones or any cell phones, I've sort of divided them up in sort of 3 pieces. Sort of your primary entry point, which is sort of I send you a text message and your phone's owned. That's obviously the most interesting one. The secondary one, I didn't really end up getting much of that stuff done, but it's sort of the apps that are on your phone by default, but you need to enable something, like email or IM or something like that. I sort of see that as a secondary entry point. And then sort of the last part, I sort of divide up into 2 pieces. One which I call proximity attacks, which is sort of these things where it would have been a primary entry point, except you have to be close enough to the phone to get there. You can't just send it over the network. And this, of course, includes Wi-Fi, Bluetooth, or I guess some of the baseband stuff. And then, most of all, what I call the non-zero-click attacks, which is basically specific apps on your phone. And clearly there's a lot of them, and then that field's ever growing, so I figured I should include it. And there's some interesting stuff in there. And that's actually one of the pieces where there has been, there's been a lot of research about some of the SMS, MMS stuff, and there's been research in recent years about the baseband stuff, and there's been research about Bluetooth and Wi-Fi and that kind of stuff. There hasn't been that much been said about cell phone applications. So I've got, most of my interesting stuff is in there. So let's start off with the primary entry points. Primary entry points basically an SMS, EMS, which is basically just SMS, and MMS, which is just built on top of SMS, sort of. So let's start off with SMS, which is on itself interesting and is basically a transport mechanism to send other stuff through. At its very most basic level, when you send over an SMS, it kind of looks like this. And maybe, or probably, if you're sitting here, you've seen this picture before, something that looks like it, but I figured I'll cover it anyway. So the way it works is at the most simple level, and you have two users at the same provider. You've got one phone which sends an SMS submit and goes to your SMS sender, and the SMS sender says, oh, it's this guy, and finds this guy and says, here, I got an SMS from you, and it says, it's an SMS deliver. And then the phone receives it and parses it and does what it's supposed to do. At a slightly more advanced level, I guess, would be two users at different provider, where there's sort of a layer in between. I don't really care about layer in between because it's not the stuff I want to do, but it gives a somewhat clearer picture of what's going on. So basically, you send a phone to your SMSC, and the SMSC contacts the SMSC of whoever the provider is, and that one sends the deliver message. This part, I will not talk about it. That's black magic as far as I'm concerned. So now that we know there's SMS, how do you actually get your phone to send raw SMS messages? And what do you send? In a raw SMS PDU, basically, it's a very trivial thing. The first thing you send in there, you have to have the phone number of your SMSC. And that one is actually pretty easy to get because they'll push it down to you anyway, and you can just go to your modem and say, give me the number. The next thing you put in there, obviously, is who do you want to send it to, another phone number, your victim, I guess. And then basically there's a couple other bits and stuff in there, and then you say, what kind of SMS do you want to send? Usually you want to send a submit. SMS at a kind of basic level sort of does interesting things in that by default it's limited to a very short 160 bytes, but you can do compression, which means it can actually be decompressing, it can be a lot more, and the compression decompression itself is actually not, it's interesting in that it's language dependent. It is one algorithm, but it's depending on the language, it does different things. Obviously, it can do Unicode, which is also interesting. We'll see a word about that later on. And it can also concatenate SMS messages, so you can have fragmentation, which is also interesting, and I'll say another thing or two about that in a couple of slides. So how do you actually get it? How do you get the thing to send raw SMS PDUs? It's not really documented in the sense that the phone makers don't want you to do it, but they don't go that far out of their way to prevent you from doing it. They just don't. They're not going to give you a document API to do it, but if you really want to do it, it's not that hard. The first way I found out how to do it is that on the Android, there actually is an API to do it, sort of. It's there, but it's a Java method and it's a private one. But you can sort of play around with the method and make it accessible anyway. Some Android phones do it, others don't support it. As luck might have it, my phone didn't do it, which is kind of annoying. This is if you want to do it, this is how you would do it. Basically, you figure out the method on your object, and then you basically mark it and say set accessible, and then you can just invoke it. So I didn't go that route. What's the other way to send out SMSs? Turns out these things just expose a modem, and it's kind of like if you ever done faxes or old PSTN stuff. This is very familiar to you. You send out AT commands to this modem. And so obviously you can just do your usual AT commands, ATA and ATD and ATH and so on. Those will work. There's also what's called extended AT commands, which is the ones that we really want to play with, which they're called AT and then plus and then some other command name. Turns out, so the old well-known ones are ATA, ATH, and so forth. And then some other stuff for the extended ones are if you ever play around with sending out faxes, then that gives you a fairly good idea of what extended AT commands look like. They're not that hard to understand though. The chips actually usually do expose the phone, but there's no official documentation. There is, but you have to sign away your life if you actually want to read that specific documentation, because you have to sign NDAs from the manufacturer. There is non-official documentation, of course, which is fairly well understood and fairly well explained stuff. Some of the commands that were unofficially documented depends on the phone. Some phones support more than others, But in general, most smartphones nowadays will support what you want or what you need to send out raw SMS data. There's actually some interesting, there's a really good manual about it, to link right there. And basically, you have these are there's about 7 or 8 interesting extended AD commands for sending out raw SMS that you want to know about. I'm not going to go over them, but that's basically the list of the ones you want to look at. The one that is really most interesting one is the plus CMGS, which is the one which says, here's my raw PDU, send it out right now. Don't do anything with it, just send it out. And then there's other commands where it basically said, don't send it out, but store it on the phone, and so forth and so forth. It's this easy, really, to do it. This is on my N900 Nokia phone. I did most of my development, I should say, on the Nokia N900. The reason why I did all the development on that phone is because it's not locked in any way. It's basically just a Linux box on an ARM chip. And it's made to be that way. They actually, if you go to their app store, they have an application on there, an officially supported application called Gain Root, which is if you run this application, you jailbreak your phone. So it's there by design. They want you to play around with it and write code for it and do all these things. And it comes with a great tool chain. You've got GDB on there and GCC, and you've got Perl and Python and so forth. So that's why I chose that phone, because there's nothing standing in my way to do things. And so if you want to send out raw text, and you don't even have to actually talk. I mean, you do have to talk to the modem, but the people who made the N900 said, we're going to make a program for you, and you just talk to that program, and that one will send out, and will talk automatically to the modem, so you don't have to mess around with device names and stuff like that. It's called PNAT-D, basically. And this is exactly how this is how easy it is to send out. You basically just type in stuff, and you do the character return and go straight to the modem. And so obviously the stuff you really care about is the thing that's here in red, which is sort of the raw or hex raw bytes of the raw SMS stream that you're going to send out, or SMS PDU. So what does that thing really look like? Basically the first set describes the SMSC you want to talk to. It basically says, this thing is so many bytes long, which is the first field. The second field says, I'm going to describe the address in this particular format. 0x91 is one of the most common ones. I think 0x81 is also a common one. There's an entire spec which is like 50 pages long, say, documenting a whole range of, you can do it this way or this way or this way or this way. There's really not, there's a lot of leeway into how you want to form the phone number. And the way the length's calculated is interesting. The way so you also have to give in the length of your SMSC bit. And the way that's basically calculated is that it takes the count of every byte, not every hex byte, but the count of every byte. This is important because there's another number further on which does the length calculation differently. The second byte is actually the one is one of the ones you really care about. It says basically it's not really a byte. It is, but it's a set of bits, and basically says this bit does this and this bit does this and so and so. And basically it allows you to say I'm going to be this type of SMS, a submit or deliver or whatever. And there's a couple others in there. There's one specifically in there, which is a bit, which says, does this SMS PDU have a user data header or not? I'm going to talk about user data headers in a minute, but you want to remember that because it's kind of important. And then there's a set of PDU types. The 3 most common ones are SMS submit, deliver, and then there's command. And there's a bunch of others though. But the one you really want to care about is if you're going to go and try and own phones, is SMS submit, because that's the one you use to send out raw PDU, SMS PDUs. There's a reference number, which is, it's important if you do like concatenation stuff like that, but you can just set it to 0, and the SMSC will generously generate one for you. This is basically another sort of phone field which is nearly identical to the one for the SMSC, and this is the one where you say, I want to send it to this guy. The one thing that's different is that the length calculation isn't the number of raw bytes, it's the number of hex bytes, which is kind of weird, but I guess that's how it works. Protocol identifier. I didn't bother to read what it is, but everyone told me that just set it to 0. So I'm like, okay, I'll set it to 0. This particular byte is sort of says the encoding of the content. And it's kind of interesting because the encoding is kind of weird. By default, if you set it to 0, it does what's called GSM 7-bit encoding. And then there's 8-bit, which is basically just raw data, and then there's, you can also set Unicode. Now, if you're going to send out normal text messages, then GMS 7-bit is usually what you're going to use. I guess depending on the country, I'm sure some countries will default to Unicode. At least when I play around with stuff, the phones I have, which are set for the I live in Belgium, so they were sold to me by Belgian manufacturers, and at least there, by default, all of the phones used 7-bit GSM. 7-bit GSM is not, it kind of looks like ASCII, but it really isn't. And the way it works is they have a table of 127 characters, and so A to Z, capital and lowercase, as well as numbers, map 1-to-1 to ASCII, but that's about, there's a couple of special characters, but most special characters are either not there, or they're sort of mapped to something else. And so what's interesting is that, for example, the @ is mapped to the 0 byte, which turns out was interesting in the past because there were a bunch of encoders and decoders written for this stuff, probably in the mid and late 90s. In the C language, where the 0 byte has a special meaning and it caused problems in encoders and decoders because it would be the string terminator. And so you get this sort of mangled SMS if it even arrived, or the decoding would fail or whatever. I know the Perl SMS decoder had a problem with that for a while too. It's long been fixed, but it's interesting from a historic point of view that they mapped this particular sign to the 0 byte. There's also, so basically what they do, so once you have this table, it's all 8 bits, but it's only, they don't use the most significant bit. So what they do is, and that's why it's called 7-bit, I guess, is they don't just take away the bit, which would be the most obvious thing to do, but they sort of shift it. So you have the first 8 bits, and then they take the second 8 bits, and the least significant bit, they sort of shift into the first one. And then you end up with 6 bits and 2 unused bits, and the next one they shift it into there. And that's the way you go all the way around until you're at the end of your message. That's how it works. The other interesting thing is, if you look at this table, you've got a bunch of characters in there, and then there's a bunch of like Greek signs and whatnot, stuff I've never touched in my entire life. And they're all in this table. And then I think when somebody made the table, I said, oops, we forgot a couple of characters, but the table's full, what do we do? Some of the characters they forgot was the caret sign, the backslash, and the curly brackets, and the pipe, stuff that people like us might use if you want to send something to someone. Chances are some of these characters might be in there. So they said, oh, we'll have a special case for these ones. We'll, instead of use 1 byte, we'll use 2 bytes for this one. And so for these 6 or 7 characters, there's 2 bytes instead of 1 byte. And then those 2 bytes, again, get encoded into the 2 8 bytes into basically the 7-bit encoding. So, and the rest is basically the content. Appended with a length field, and then you basically just have your PDU content. So that's how you send it out, and that's how it looks. Now, I mentioned earlier there's this bit about the user data header. That one's actually really important because what I described earlier, this thing is basically, that's a text message, as in just text. I send it to you, and it doesn't carry application data or anything like that. It can't do that. But if you set this user data header, all of a sudden it can. So the way it works is sort of that your SMS content now has an extra header in there, which is the user data header. And that one's actually a very simple type linked values set, where you can have a number of types of links and values. And they basically just look like this. So it's this very simple thing where you've got 1 type linked value and 2 type linked value and so and so and so until you got till the end of your type linked value. So it's a very trivial thing. And so you can have I guess, you can have unlimited, as in, there's a limit as to the amount of data you can send, but in theory, I guess, there's no limit as to how much you can send. So Basically, so the type basically says what kind of content is, or what kind of specific application type SMS am I going to be. And all of these are potential entry points for if you want to go and break phones. And they allow sending of WAP and graphics and ringtones. And there's a spec that defines this stuff, and the list is huge. And all this stuff is stuff that potentially gets parsed by phones. And there's EMS stuff in there, and there's WAP push and other kinds of specific SMS control stuff in there. This is all fun stuff to sort of play with. And the table continues because it's a very long table. And there's even more stuff in there, but I figured I'm not going to waste 3 slides on it. So the other thing about SMS, which I sort of mentioned earlier, is that it supports fragmentation, compression, and Unicode. This is very interesting from an attacker point of view, because fragmentation, we all know, if you looked at any of the interesting TCP/IP kind of stuff in the mid and late 90s, there's all sorts of funny things you can do if you end up having fragmentation of protocol. SMS is kind of similar to that, so there will most likely be similar issues, I think. At least there's been already one, I think last year by Charlie something, can't remember his name, but it was a buffer overflow in the iPhone, which was specifically about the fragmentation of SMS messages. The other thing I've been thinking about is, if you do the SMS, so one of the things that initially, if you look at the TCP/IP version of fragmentation, is that this stuff has been used to do IDS evasion. So I'm thinking you could probably do the same thing to avoid lawful interception, where if whatever lawful interception appliance concatenates all these SMS together, they get a very different view than what's actually being sent over. So there might be something to that. Second of all, there's compression in there. So compression, again, if you look at stuff like settling and stuff like that, not always trivial to get right implementation-wise. So there's definitely potential there to look at compression for potential bugs in phones. The other thing I'm thinking is decompression bombs. It may not lead to buffer overflows, but it might lead to your SMS parser suddenly dying, and it turns out in most phones your SMS parser dies, you're not going to receive anything anymore. Your phone's not dead, but you're not going to receive or send out SMS or phone calls like that. I know at least Android works like that. So you have to basically reboot the phone to restart the telephony application. And lastly, the SMS also supports Unicode, which again is interesting because there have been, if you look historically at Unicode implementations, there have been issues with buffer overflows and encoding and decoding. There have been issues with sort of trying to validate something in Unicode, and then you map it to ASCII, and then you get this or many-to-one mapping, and you get totally different characters. So there's interesting stuff, or potential interesting stuff with Unicode in the SMS too. So that's as far as my SMS intro goes. Second part, MMS. MMS at its basic part, again, sort of the graph, which we saw earlier, but now instead of SMS, we're talking about MMS. It's, I guess, if you look at it from high level architecturally, sort of kind of the same in the sense that I send my MMS, I upload it to my MMS center, and the MMS center goes back to whoever I want to send it to, but it doesn't actually deliver the content there. It sends an SMS and says, hi, I'm a WAP push message, basically, which is really goes over SMS and says, hi, I've got content for you. Here's a URL. Why don't you go and fetch it? And then it goes to the WAP server installed by the telco provider and goes there and fetches the content. To play with this and to test it is kind of annoying. You don't want to do this. Mostly because you run into the telco, and first of all, if you start putting funny stuff in there, some of their stuff might break, and they may not like it, and if they don't like it, they're going to come after you, or more likely, they're going to send their lawyers after you. So you don't want to do that. And even if you don't break anything, it still generates a lot of noise, and you still end up in the stuff where the telco provider may not want you to play around with this stuff. So the way to fix it is actually really easy. This message, you can just forge it. You can build it yourself because it just goes over as a message. You can just forge it, send it out, and so you avoid the whole MMS thing. So you send it yourself, and you give them a link, and you say, why don't you go to my web server instead of, right? That's how it works. I didn't come up with this, by the way. This has been done before, but I thought it's a very fun thing to do. And so now you also afford. So so in the previous picture, if the MMS if implemented in the sense that they said we're going to make sure and we're going to do IDS detection and shellcode detection and this kind of stuff, and we're going to re-encode images to make sure nobody can do any funny business, then all of a sudden you just circumvented it, right? So that's how you would do it. And this stuff's very easy to do. So how do you go about doing that? So you have to set the UDH bits in your SMS PDU, and then you have the UDH header, which I'll show in the next slide. And there basically you fill in the bits, and then after that you fill out the WAP data, and at the end of that there's a link where you can basically set your stuff and send it to the phone, and the phone will go out and get it. So what does the UDH look like in this case? It's basically just what's that? I guess 7 bytes. Basically, so so here you have the length, type, and value. And basically, the length is because it's 6 bytes, obviously, and 5 is basically which says I'm a 16-bit WAP port or an application port, and these are and you've got 2 ports. It's kind of like TCP and UDP in that the stuff basically uses 16-bit ports, and there's a source port and destination port. So in that sense, it's very much like TCP and UDP. And then obviously there's a length field describing the length of this stuff, even though you wouldn't need one because they're defined to be 16-bit, but it's there anyway. So that's how you do it, right? And so if you want the MS specifically or the MS notification, then you have to have a specific source port, specific destination port. The source port is always 2948. Destination port is 9200. And that's basically the WAP push. And then basically you have to, if you look at the spec of WAP push, this stuff's pretty hairy though, but it's all fairly well documented. Then basically after your header, there's sort of this, I guess, application data, which is it's called binary XML, and the reason why obviously is because normal XML is very verbose, and there's so much redundancy in there, you don't need all that crap. So they sort of compress it into sort of what they call binary XML, which is a very, very weird thing. And binary XML itself is very interesting because there's length fields and sizes and offsets and indexes in there, so that's stuff you can play around with. Very interesting entry point. And basically, it's got to come from the right source port and destination port, as mentioned earlier. So if you actually want to forge it, this is how it will look, basically. And because I had to play with stuff around, so I documented, at least I think I documented fairly well in my source code. It's basically the way you do it is, first thing you got to say, what is, you have to actually describe the content of, that's inside the content of your SMS PDU. Say, what is this? Describe the thing that it is. And so you say it's an MMS message. And then you say, well, what kind of SMS is this? Well, it's a notification MMS. So, okay, that's very interesting. It's what kind of version? What's version 1? And so you got to fill out more and more of this crap. You got to say, well, what's the size? And then stuff like, say what's the message size, but what's the size of the message size and stuff like that you got to play with. And then once you get through all of this sort of boilerplate stuff, finally at the end you say, here's where I want you to go and fetch stuff for me. And so in binary XML, I guess I forgot to put it in there, all the I guess strings that are still left over in binary XML, basically the way there's no length field describing them most of the time. It's really just, it's kind of like the C programming language where every string in binary XML just ends with a 0 byte. So again, 0 byte has special meaning. So that's how it looks, basically. This is basically how you would send it out. Interesting point of view from there is that you can, I didn't put it in here, but you can have, or you can omit it, but you can have a from number in there, which isn't validated by anyone. So you can basically spoof it and say, someone you don't like, you could maybe send them an MMS with some nasty pictures and then spoof it from somebody else, right? So you could pull tricks like that. Obviously, the binary XML itself is a great entry point. There's so much crap that has to be parsed in there. I haven't heard of any yet that have been broken, but there's got to be piles and piles of stuff in there in the smartphones. The The other thing in there is that once you give the URL, the client goes to my web service, is that it's really kind of it's a user agent, right? It's a very trivial browser, basically. So that exposes HTTP-like parsing and content, and so you can play tricks there too. And then basically it fetches an XML file with a bunch of headers in there, and then there's your binary content, which is usually like an audio format or video format or whatnot. Also, because it has to go out, it may expose TCP/IP stack. Now that depends on your provider and stuff like that, because some of them will use proxies, and if you use proxies, they won't. But if some of them may very well say, well, why don't you just use your own TCP/IP stack and go fetch this stuff. So may or may not expose TCP/IP stack depending on settings and telco provider and things like that. But again, if it does expose TCP/IP stack, that's a huge entry point, because on the desktop side and the server side, TCP/IP stacks are fairly well tested. On the embedded side, not so much. There's a bunch of embedded appliances that easily break. If you run Nmap on this stuff, they break, right? So chances are phones are fairly similar. So that's the MMS sending part. I'll go into secondary entry points, so I didn't actually, because I sort of rushed this thing together, I didn't actually end up, I didn't have enough time to look into the secondary entry points. Most smartphones these days have email. Obviously, there's interesting stuff in there, vCard parsing, HTML header, email headers, that kind of stuff, attachments, but I haven't looked at it. So I will in the future, but I haven't gotten there yet. So let's look at the third entry point, and I'll start with the proximity attacks, and I'll move on to the application stuff. So basically, proximity attacks, I've sort of divided up into four pieces, which is basically what most phones either come or used to come with, is basically Bluetooth or Wi-Fi and your normal baseband, right? So I'm not going to talk much about Bluetooth. This stuff is pretty well understood. There's been work about this, a lot of security research from this stuff, mostly by the Trifinite guys, Martin, Marcel, Adam. A bunch of people have looked into this stuff. I'm not going to talk about it today. It would be a waste of your time for me to talk about this, because there are people who understand this stuff much better than I do. URDA I will talk about. Initially, when I looked at these phones, I said, well, why don't I go do URDA? And you start to look up, and very few people have ever done any security research on URDA. It's always, if you look at these sort of phone stuff, people always mention, oh, you have Bluetooth and Wi-Fi, and then there's URDA. And then there's been stuff done on Bluetooth and Wi-Fi, but nobody ever looked at URDA. I was like, oh, that's interesting. Why don't I go look at that? Now I found out why nobody's ever done it. Because nobody ships phones anymore with URDA on it. It turns out that's the way it is, I found out. Some phones, like the N900, do have an IR transceiver, but they said, we're not going to give you an URDA stack, screw you. It's there because you can use it as a remote control, which makes sense, but you can't do the URDA anymore. I tried very hard to find a phone somewhere that in mobile stores near where I live, because to find a phone that they would sell me that has URDA, I couldn't find one. I've been told there's still a couple out there, but I couldn't find one. But I still thought, there's nothing done there. I want to go look at it. But I'll only observe this from a distance because I never got to send it to an actual phone. When I started looking at some of the URDA stuff, and first thing you do is when you hear about something, you say, well, why don't I Google the stuff and see what comes up? There's a very interesting security advisory that came out from Microsoft about a decade ago about a denial of service buffer overflow in their URDA stack in Windows 2000. The advisory is very interesting in that it says so and so and so, and it's the URDA stack, and it's a conduct a buffer overlap and cause an access violation in the Windows kernel. And then they go on to say, this cannot be used to run malicious code. Absolutely cannot be used. I don't know about that. I didn't look at the specific bug, but I think that's kind of a bold claim to say, on one hand, we have a buffer overflow, which we know causes an access violation. On the other hand, we're here to tell you that there's no way this can be exploited. Tricky thing to do. I guess that it kind of makes sense if you look at the date. This was done 10 years ago. Nowadays, probably Microsoft wouldn't put out an advisor like that anymore. But it's interesting, it's never been corrected. It's still there, that's how it looks, that's how it is. So I just thought it was interesting to sort of see denial of service and heap corruption is in the same. It doesn't make sense to me, right? If you have heap corruption, even if you don't examine further, at least you have to allow for the possibility that somebody else who's smarter than you or has more time than you or is more committed can figure out a way to exploit that buffer overflow. So I think that's a very bold claim to say that it cannot be exploited. So basically, this is the way the protocol looks. There's a bunch of the low-level protocols are mandatory, and then the high-level protocols are sort of, oh, are we going to support Ethernet over ERDA, or are we going to do OBEX, or are we going to do so-and-so? These are optional protocols. And so if you were to attack ERDA, obviously you want to look at the lower-level protocols, because that's the fun stuff, right? Again, I never had a phone, so I didn't actually get to go there and do this stuff, but I do have access to the Linux kernel sources. And it's like, well, why don't I go poke around there for a little while? And spend about half an hour pulling up the Linux networking stack, specifically the ERDA stack. This stuff's a mess. I mean, again, I think nobody ever looked at it from a security point of view. I spent half an hour on this stuff. I got 3 buffer overflows in there. And not hard ones. This is very trivial stuff, like string copy, string overflows in the Linux kernel, right? So interesting though, when I went to submit the 3 bugs I had, turns out one of them was already fixed. So at least somebody looked at some point. So when I looked at stuff, I was like, well, you know, this stuff is ripe for the picking. Chip, you know, it's fucking dead. The phones don't have it, which kind of bugged me. It was like, okay, well, at least I have some interesting bugs to show. Other appliances that use Linux kernel that do use the ERDA stack obviously used to be vulnerable to this. Bugs have been fixed for a month and a half or so, but they used to have them. But clearly no phones have them anymore. So the first one is actually sort of we take a binary string, but really want to use it as a C string in our code. Why don't we take the length that you tell me the string is and use that one to zero terminate this thing in memory without actually validating your length. That's a very trivial, very clear case of buffer overflow. You can just say this length is not 5 bytes, but it's really 255 bytes, and the buffer is only 5 bytes, and so you smash a byte. Very clear case. Other one, again, very clear string-based buffer overflow. This one was my favorite of the 3 in the sense that whoever wrote this actually went out of his way to try and make sure there's some validation done. Because there's clearly a length check being done, except the length check basically says the data we're going to read from, make sure that that buffer we're going to read from is big enough. Except there's never a second bound check which says the buffer we're going to write to, make sure that buffer is big enough too. So it's kind of sort of this, well, we think we did all of it, and then you miss the more critical bug in the code. And then again, you know, the string-based buffer overflow, and then zero terminates, so both of these things basically cause an overflow. So that's sort of my exploration of the ERDA stack. Again, I briefly looked at some of the Wi-Fi stuff. There's a lot of stuff done in looking at the security of Wi-Fi stacks. I spend all of about 10 minutes looking at this stuff. Basically, what I did do is there's Scapy, which is an interesting networking tool, which has which supports most of the low-level Wi-Fi protocols, and it also has a bunch of fuzzing methods. So it's like, and there's actually a presentation where someone says this is how to do it. So I read the presentation and says, oh well, let's do this and see what comes out. Not that much luck. So at least the stacks are in incredibly bad shape. But then again, I only spend about 10 minutes on this stuff. But if you want to do it, you know, you follow the steps here. You send out fuzz beacons and stuff like that, and hopefully you'll have more luck than I have when you're fuzzing the Wi-Fi stacks of smartphones. Yeah, I got this because this is not my slide. I got this from another slide deck, a presentation someone else did, which it's very interesting in its own, which is a blackout presentation. So the baseband stuff, as I mentioned earlier, I didn't touch it. I stayed far away from it, but it's there. It's an interesting entry point. If somebody wants to look at it, that's definitely one of the interesting things to do. And I think quite recently, someone from the University of Luxembourg actually found a bunch of really interesting baseband bugs in like the 4 baseband stacks that are actually shipped. But I know there's been, in the last 2 or 3 years, in the open source community, there's been a tremendous amount of coding done in terms of trying to, allowing mere mortals such as myself or anybody else to do the baseband type stuff. And so you have OpenBSD and OpenBTS and that kind of stuff. I didn't go there because, first of all, it's massive ramp up time and you have to buy the hardware. But most of all, I'm not quite sure how legal it is where I live. So it's kind of like I don't really want to get in trouble just with playing around with this stuff. So I said, interesting, very cool people doing it, but I'm not touching it. So now we get to the sort of non-zero-click remote attacks, or the sort of the applications that the highest, more high-level layer of smartphones. Turns out this stuff does take a while to get up and running and play around with. So initially I had a set of 6-7 phones I was going to play with. I only made it, only ended up playing with 2 phones. I did a little bit of Android stuff, but I didn't get anywhere in terms of security. So I'm going to cover iPhone specifically, and then there's going to be a little bit of BlackBerry stuff in there. And this stuff is very much in the works, and I've got interesting things in there, but I don't have them in my slides because they're not finished yet, and there's a bunch of questions I have. This is definitely very ongoing. And this is sort of where you go from, we've covered all the stuff which is sort of the standards and described, and every phone does it in the same way, and now you get to the point where every phone is very different, in that every environment of every phone is very different. And so I'll describe the environment of those 2 phones I looked at in the slide, and then basically go into, this is security-wise, this is kind of tricky on this phone, this is kind of tricky on this phone, and so and so. So we'll start off with the iPhone, which is the one I played around with most, and which is very interesting because it also very much resembles macOS, since it's sort of a port of macOS to the ARM CPU. I mean, there's lots of changes and stuff like that, but at its very core, it really is just macOS and an ARM chip. And so, since it's basically macOS ported to an ARM chip, it has a similar development environment in that most stuff, especially the GUI stuff, is all Objective-C. And I'll talk about that more. And so the cool part about Objective-C basically is that it's not, most of the phones actually, like Android and BlackBerry and so on, they don't give you a native language. They say, here's a very limited set of APIs, usually Java, and you only get to play with that. macOS doesn't do that. I mean, they restrict it in terms of policy, but not technology-wise. So you can actually go out and build an app and say do so and so and so, or there might be apps that do just, I mean, there's still kind of a black box, but it's not really that hard to break. You have the sort of low-level native code apps running on iPhones. And they're all Objective-C, so parts of it will do their own memory management, stuff like that. And so that's interesting because there's going to be buffer overflows and things like that in there. So I'm not going to talk, by the way, about some of the buffer overflows and standard C-type stuff because that's fairly well understood, and I'm going to try and limit it to specific iPhone application stuff. First part is that the thing about iPhone apps is that, as I mentioned earlier, is that they don't really try to limit you technology-wise. They only try to limit you policy-wise, and because you have a native language, there's only so much you can limit, right? But they'll say you can't do this and you can't do that, and we're not going to give you an API to do this. But it's C, so if you'll give me an API, I'll build my own API. But if you stick to the standards and stick to the APIs, and you want your app to go to the App Store, one of the things you can't do is, or you're not allowed to do, is to talk to other applications, which is very annoying because one of the things iPhone application developers want to do is they want their apps to talk and exchange data and stuff like that. So they figured out a sort of hack around it, which is the use of URL handlers, which is kind of sort of a problem. So basically what happens is the application will register an own URL handler, and they'll have a callback function for that, and then the other application basically calls that URL and spins up your application and sends it a bunch of data. Very simple IPC mechanism. Kind of looks like this if you were to develop this kind of stuff. So it's basically handle open URL API. Problem, anybody can do it because it's a global URL handler. If you have an app that does this and your mobile Safari goes to my web page and I say, well, why don't I call that application? Then all of a sudden, I get to talk and send specific data to that one application that you have that I didn't really expect. So that's an unintended consequence. People are sort of very, very slowly figuring out that, well, maybe we should just do some validation there. But initially when this stuff came out, and most applications that do this stuff don't validate any of this stuff. So there's very interesting consequences in there in the sense that the data that's coming in these handlers is also trusted or assumed to be trusted. So if you find a bunch of applications that registers URLs and you play with it just from if someone browses your some iPhone user browses to your website, they get to send all this arbitrary sort of interesting data to these IPC mechanisms that applications have registered. And there are literally thousands of apps that have URL handlers. And there's actually a website that documents this stuff. And if you go there, looks like this, and the first thing it says is share inter-app communication. Now, isn't that fantastic? And there's, because basically if you look at this website, it'll list, probably not all, but most applications says, this URL handler does so and so and so. So you have great documentation right there. Obviously a source of inspiration. So the other thing about the iPhone, and this is the thing the thing I really like the most, is that you can have cross-site scripting in the iPhone. And now I know if you say cross-site scripting, you're like, well, okay, we've been there and it's web app stuff, and it's only not really on the iPhone. It's slightly different. And so basically on the iPhone they have what's called a UI web view class. And it's a way to build up a GUI. There's different ways to build up a GUI in the iPhone, but this is one of them. And this one in particular is used usually in cooperation with a web app. If you send out an application for an iPhone, which is supposed to be a GUI or a front end for a web application, then 9 times out of 10, a UI web view will be used. Now that's interesting because what a UI web view really does is it basically says, build up a bunch of HTML, raw HTML, you hand it off to the UI web file class and say, render this stuff. And it basically sort of kind of like a browser. Obviously vulnerable to cross-site scripting. If no sanitation is done or there's not a sufficient escaping of data, it can be vulnerable to cross-site scripting. At a very basic level, there's no cookie, so you can't do that. But since this thing is a UI and it will obviously have interesting stuff or hopefully we'll have some interesting stuff in the phone, you can just sniff the entire UI and send it back to, if you send it back to yourself. That's sort of the very basic level. It gets worse. By default, there's no, so it's just HTML and you can have JavaScript in there and you can script this stuff, but there's no bridge back from Objective-C or from JavaScript to Objective-C, which I'm sure was intentional, except iPhone developers looked at this and said, yeah, but I really want there to be a bridge because I think this stuff is cool and interesting and I want it to be there. So there's a way that you can actually build one, and lots of iPhone developers saw this and said, oh, great, let's implement this stuff. And so you can create a hook, which is a should start loading with requests, which is basically a URL handler, but very specific to that UI web view. So it's not a global one. Only stuff that's rendered in that particular view gets to call that URL handler, and basically pass data to it. Now, the assumption here is that when people build this stuff, is that when this stuff is being sent through this URL handler, is that it's only going to be trusted data that's built up for the UI to render. Which is true, except if you have cross-site scripting, because if you have cross-site scripting, the content's no longer trusted, right? Basically, that means these URL hooks are not built to handle untrusted data. Everything that goes in there, I mean, 9 out of 10 of these things that I've seen, they break instantly, like out-of-bound index and stuff like that, because they assume, I've seen one that had like pointers in there and stuff like that, where they basically said, well, take a blob of data, put it in the UI, and then the UI will send it back to me, stuff like that. So if you get cross-site scripting in these kind of things, depending on the application, depending on what they do with the URL handling, you can get memory corruption and stuff like that in there. Now it gets even worse in the sense that people have said that it's very interesting, but what I really want is I don't just want to handle some data. What I really want is I want my JavaScript application to be able to call arbitrary Objective-C methods and basically call native code. And so there's code out there which basically serializes and unserializes arbitrary method names and arbitrary arguments. And people use this stuff, and this is basically what it looks like. And this is really cool because if you have, this is like by design, right? So if you have cross-site scripting, an application that works this way, and that's the serialization and unserialization of Objective-C function names or method names and parameters, then obviously, you're done. You've got code execution right there. So I thought that was very interesting. The next type is sort of format string bugs. I know format string bugs are obviously very well understood, and the myth about format string bugs is that they're mostly dead because they're so easy to detect and nobody has them in applications anymore. Well, in come the iPhone developers who have no concept whatsoever of native languages, and they see this Objective-C language and then they sort of play around with it. And if you stick to the Objective-C objects, you're mostly okay. I mean, you're mostly okay from the application developer point of view. The objects themselves have issues too, but that's a problem for Apple, not for the developer. So if you stick to those objects, you're kind of okay. So you're not going to. Most iPhone apps don't have that many, or shouldn't have that many buffer overflows and stuff like that, because they're going to use these Objective-C objects, which can handle strings in a very elegant way and things like that. But these methods do come with format functions, and so from the iPhone applications that I've seen so far, there are more format string bugs than there are buffer overflows and read AVs and that kind of stuff. Buffer overflows, format string bugs are rampant among iPhone applications, as far as I have seen in the ones that I've investigated. So basically, yes, they can lead to format string bugs. iPhone developers, they don't really, I'm sure they know what a format string function is, in the sense that it's documented, but they don't understand the consequences of doing it wrong. Nobody ever told them and said, don't do this, because if you do this, horrible things, these format specifiers have special meanings and they pop stuff from the stack and they handle pointers and stuff like that. Most iPhone developers don't know this stuff. At least, I don't know if they don't know this stuff, but it's evident from the code I've examined and the applications I've looked at that they, as far as I know, they don't know. These are the methods these are specific Objective-C methods, basically, except for the NSLog function, that are basically just Objective-C methods that are potentially vulnerable to format string bugs if used incorrectly. Now, they're sort of different from your standard format string function in that they don't support the %n format specifier, which is the thing that makes format string bugs really cool, because it allows you to write data to arbitrary positions. You don't have that in Objective-C format functions. I'll talk about this in the next section, but there's a punchline to this, I promise. And next, basically, I guess a special application in the iPhone is the browser. The iPhone browser is a disaster waiting to happen. This stuff will parse anything you throw at it, and the user doesn't know. Like, they'll browse to my webpage, and they're not going to tell you there's an Office document, you want to download it or parse it. It says there's an Office document, and I'm going to parse it whether you like it or not. And it does that with RTF files too, and MP3 and PDF and all sorts of stuff. There's a long, long list of this kind of stuff. But let's talk about the Office ones, because Office is very interesting in that it's a very, very complex file format, and it's very hard to parse, and nobody can do it correctly. And obviously that would include Apple. Basically, it's a parser, but they don't render the or interpret it as Office documents in the sense that they convert it. So they take your Office whatever and they convert it to HTML. And there's this. They have a utility or a library for this called Office Import, which, by the way, is a private API, so you can't touch it as a developer, but it's there. Office Import, I think a vulnerability, the first vulnerability, as far as I know, public first vulnerability for Office Import came out about 2 months ago in iDefense Advisory. there will be more. I'm very confident there's going to be more. So the thing, basically, what the advisory says for this vulnerability basically says the same thing that I just said, which is this stuff parsed automatically. It will parse it whether you don't want it or not. And as they say, it's kind of similar to the way Office 2000 used to work, a decade ago. Microsoft has since learned from their mistake and says, we're not going to do this. We're going to ask the user if they want to do it. Obviously, the reason why you don't want to do this is because you have a very rich feature set. But the reason you say, we're not going to parse automatically is for security reasons, obviously. Oops. So the only thing I want to say is that I'm pretty confident there's going to be more because, first of all, Office formats are incredibly hard to parse. And, same thing here. Second of all, I actually played around fuzzing with this stuff. Very, very trivial dumb fuzzing. Manual dumb fuzzing, as in I make a file, change a bit, parse it, bam, thing blows up. So and this was about 20 tries of me changing a couple of bits. So this stuff is very, very sort of shaky and wonky. And that's like ripe for the picking, right, the Office import. So the second one I'll talk about and sort of, I spent much less time looking at the BlackBerry because I spent a fair amount of time mucking around and playing around with the iPhone because one, I just told you about a bunch of these cool features, and two is that the iPhone, in terms of playing around from a security point of view, is far less restricted than the BlackBerry. The BlackBerry does a lot of things right, whereas the iPhone guys didn't, I wouldn't say did things wrong, but they just didn't really consider security when they implemented this kind of stuff. BlackBerry is, they've got their own OS. I don't know if it's based on anything. I don't think so. I don't know. But it's proprietary, and there isn't that much known about it as far as I know. The applications are all written in Java. It's all managed. They've got a bunch of extensions for their own. The only thing I know that I've looked at and seen and then where things go wrong about the BlackBerry is that the BlackBerry, unlike the iPhone, does allow apps to talk to each other and share information, and so developers don't have to invent these wonky IPC mechanisms. And the way they do it is they have these persistent storage objects, and they're really they have 64-bit identifiers, and you put stuff in there, and another application can pick it up and go there. By default, the ACLs are basically there saying anybody can touch this stuff, which is interesting from a privacy point of view, where if you have one application which stores a set of data that you really don't want anybody else to read, such as cryptographic keys and that kind of stuff. I've seen that happen, by the way, where people say, well, take your crypto keys and just put them in this persistent storage and have no ACLs on it. So that's the thing, right? There's no ACLs on there by default. The good thing, though, is that this is very much documented. If you go to the BlackBerry Develop website, they'll tell you, you can put ACLs on this stuff, and if you're going to put sensitive stuff in here, you better damn well have ACLs. So it's all documented, but it's not on by default, and so there's a set of BlackBerry applications that when they do persistent storage, they won't do the ACLs, and if they, I would imagine, I would imagine that there's at least a couple of BlackBerry applications that store sensitive content in these persistent objects without using ACLs. So that's really the only thing. I haven't spent that much time on BlackBerry, but that's the only one thing I could find where I was like, well, that's applications are vulnerable to this kind of stuff. And this is if you were to ever audit BlackBerry applications, it would kind of look like this. Basically, that's how to use this persistent object stuff. So I talked about the iPhone browser. I spent a little bit of time playing around with the BlackBerry browser. I know people say it sucks from a functionality point of view. So from a security point of view, it doesn't suck, at least not as badly as the iPhone one, in the sense that they will parse very, very little that you throw at it. Almost always they will say, do you want to download this? And you have to download it first. You don't get to render it immediately. You have to download it first, and then you can say, well, I really want to open this stuff. So from that point of view, the browser is significantly better than the iPhone. I haven't really sort of looked beyond this part. in the BlackBerry applications. But the general sense I'm getting is that if you compare it to the iPhone, people put thought into this stuff, and this stuff, from a security point of view, works a lot better than the iPhone from a security point of view. Okay, so the next, so this is sort of the, I guess, general entry points. Now I'll talk about, you have a bunch of entry points and you maybe have an interesting bug. How do you figure out what kind of phone someone has before, because you don't want to call them up and say, well, what kind of phone do you have, because I really want to own you. You don't do that, right? You want to, right? You want to write a fingerprinting application to say, to figure out what kind of phone they have without asking them. As I mentioned earlier, when you do this sort of your own MMS handling, is that there's a user agent, and the user agent goes to your web server and says, hi, I'm user agent so-and-so, give me content. That is absolutely perfect for fingerprinting, right? Again, I didn't come up with this stuff. It was a guy in the States called Zane Lackey who came up with stuff and built a tool for this. And then he said, I was asked by telco providers not to release the tool. So we didn't release it. I have code for it, and I will release it. Not his code, I wrote my own, but give me a couple of days and I'll publish it online. It's basically 2 Perl scripts. Right now it only works from an N900, but give me some more time and I might port it to other phones. But it's there, it's fully functional, it's for N900, and you basically, all you need is a phone number and about 10, 20 seconds, and you get well, given that the phone's on and does MMS support, the message goes out and fetches the stuff. It takes less than a minute to get back the kind of phone they have. And it kind of, so basically architecturally again, it kind of looks like this, and the previous picture where you go to the SMSC and say SMS submit, which is a WAP push, which ends up being an MMS notification, which you send back to your victim, and the victim goes to your server stores the user agent, then your phone goes to the server and say, that guy that just talked to you? Yeah, give me his user agent, and then basically get his user agent. And this is sort of kind of what they look like. So this stuff is very specific, right? There's no confusion there. If it says iPhone OS 4.1, pretty sure it'll be, the latest iPhone, right? If it says BlackBerry 9300, pretty damn sure it'll be a BlackBerry Curve 9300. If it says the MIMO N900, it'll be an N900, and so on and so on. So this user agent stuff is very fun. It's very easy, and it's very it makes it easy to go if you want to know what kind of phone someone's using without asking them or without ever seeing them or knowing what kind of phone they have in advance. You don't need that stuff. All you need to do is send them one MMS. Well, one MS notification even. So I'll be releasing that code. I don't have it online yet. Give me until after the conference, like the 30th, and I'll make sure it's on the IOActive website. So last part, exploiting bugs. Again, as I said, I didn't get as far as I wanted to. So I wanted to put more stuff in here, but I didn't get around to doing it. So I'll cover just one particular one of the iPhone that I played around with. So when I mentioned that there's a bunch of formats, that a lot of iPhone apps are riddled with formatting bugs, and so you run into this thing where they have these Objective-C format methods, and they don't support %n, which is kind of annoying. That's the really cool part about formatting bugs, that you get to write somewhere, right? So you don't have % anymore. It's sort of take it away. You go like, well, gee, is that it? Can I only sort of crash the application now or leak some data using %s or whatnot? Turns out the format functions are even more different in the sense that they don't only not have the %n specifier, they added one, which is the %@ sign. This one is very Apple specific. It's very Objective-C specific, but it's documented, it's used all over the place. And this one basically says it takes a pointer to an NS object from the stack, and it calls a method on it, description with locale, or description, or if it's not an NS object, but it's a Core Foundation type reference, then it calls the Core Foundation copy description calls that function. So that's fun because, well, you get to call function pointers. Which is a lot of fun because, one, it's a lot easier than, because you don't need to know a bunch of addresses to write stuff to. And I think what general formatting bugs is that you got to sort of fiddle around and get it offsets right and stuff like that. And it's kind of a pain in the ass to reliably exploit general formatting bugs. This kind of stuff is a lot more fun. You just have a function pointer and that's it, right? So it's you don't have to fiddle around so much. Of course, there's a couple hoops you got to jump through. And this stuff is not just specific to iOS, it's basically macOS, and macOS applications can be exploited in similar ways. So basically I'll give a demo of consider the following application and how it looks, and this is clearly a classic case of a format string bug where you got an argument, and then basically this is where you had a format string bug. Now if you will fire up a debugger and you run this stuff and you say, well, trigger this string, and you're given 4 bytes, and then you do one pop-up stack, because you got to make sure your address is in the right place in the stack, and then you call the %@ sign, it's going to take this 4 bytes as an address, which will be the address which is used as an NS object. And basically, obviously, it crashes in a method called Objective-C message send. And when it crashes, you can clearly see, at least one of the registers is the exact value we want it to be. So now let's go look and see what this Objective-C message send does, because that's the one that's going to go fetch the function pointer from the NS object. And once it gets the right function pointer, it'll actually just call it. Clearly, as seen earlier, we know we have full control of the pointer. So let's see what object message send actually looks like. I couldn't find any code. Well, I could find any code for it, but it's basically they wrote the damn thing in assembly. So it doesn't look pretty, but it's there. Luckily, it's a very small function. It's about 7 or 8 instructions. And I'll only briefly cover the ones we really need to understand what's going on and how to build up your data in the right way to get to executing a function pointer. So obviously the way the Objective-C message send API first works is that it takes the correct argument and puts them in the CX and AX registry. And then basically says, takes and then it references the AX, and out of this one, basically takes the pointer that we control, which is the 0x62626262. That one's the NS object pointer. So that's the point from where we start. And then you get to here, which if you go back and say and it crashes, this is exactly the point where it crashes. So which is the objective message send plus the 23rd instruction. That's where it crashes. The reason why it crashes is because it dereferences the pointer or an offset from that pointer and gets another, and basically reads a pointer out of it. And from that pointer, the pointer read out of that one, it's going to dereference again, so it's got to be some kind of structure. And I'll read out a mask value from it and mask off a bunch of bits, and then basically use that to calculate an address. And then it basically does this one. So you want to make sure that that bit mask is set to 0, because if you set it to 0, well, sort of this sort of weird little thing where if you want to get it right, you have to sort of fiddle around with it, and it's kind of annoying. If you set the address message to 0, it sort of becomes very easy, and it says just this one, and then offset 8, which is the pointer that you read from that you control. So you want to make sure the mask is 0, and so things become a lot easier to do. Once that one's referenced, another pointer is read from it. And it's very clear that it's a pointer, because the first thing they do is once it's referenced, they say, is this a null pointer or is it not a null pointer? If it's a null pointer, it's kind of, you don't want to go down that path, because that one doesn't lead to code execution. So you want to make sure it's not a null pointer. You want to make sure that's a... Okay, I've got probably about more 10 minutes, so... Maybe 5? I'm almost done. Okay, I'm almost done. So once we know it's a valid pointer, this is where stuff gets interesting, because what really happens here is they read out a structure which says, has a magic value, has some value, I have no idea what it does, and then has a function pointer. Turns out the magic value isn't really a magic value, it's really a pointer, except it's used as a cookie and that it's only used for comparison. So that means if you go and exploit stuff, you got to figure out, it's basically it's a pointer to the parent. If there's a parent class, a pointer to the parent class, and then it's the way to match up if it's a child or not. So once you get there, basically the comparison is done with the original ECX value, which is passed in, which is sort of the pointer from the parent class and then sort of they say, is this compare, is this one a child from this one? It says, if it is, jump to this location. And this is the one where you basically go, jump to this location. And what they do is they take out a function point from the structure and they say, call it. Bam, you're done, you got code execution right there. Now, obviously, this kind of looks, you're like, well, it's a point here, a point there, and it sounds very complicated. But it's not really. It's only a handful of pointers. And the other thing is you don't only really have to know one pointer because you can make everything self-referencing. Take one base and then everything's sort of a relative offset from that. And maybe it still sounds a little bit complicated. So here's how you would do it. If you wanted, for one, all you do is have a pointer to a location where you control the content, build it up. Put C code there. Build it up exactly like that. This is the one where it's going to point to executable code. This is how you do it, and you have this stuff on the stack. Get a formatting bug, or an Objective-C formatting bug, given these specific values, and that'll give you code execution. That's it.
I bet there are millions of questions to you. Okay, where's the second mic? Over there. Okay, who's got a question? Any questions? Over here. Blue sweater. Please stand up and...
Hello. Thanks for the very interesting talk. Just a small comment. I think the fingerprinting doesn't work always because often the mobile phones are configured to use a certain access point for MMS retrieving. At least in Austria, it's very popular that mobile.
Oh, is that true? I only tested.
Yes, it's typical for mobile operators use different access points for surfing or for retrieving MMS content. Well, just for billing. So
that's very interesting to know. I had no, because I've only tested this at home where I got a bunch of phones. All I can say is it works for. Clearly, I can't generalize this stuff. It works for me. I need to investigate more, but that's very interesting. I would love to talk to you later if you have more information about this. I'd love to know.
Sure.
Okay. Well, that's okay. Any other questions? Yes, over here. I'll give you my phone.
Hello?
Yeah.
Okay, a few months ago I was playing with MMS stuff.
Who was that? Stand up? Okay.
Some time ago I was playing with MMS stuff, and I'm not sure if I remember correctly, but I think I was able to fetch the MMS with my laptop, that it was a web address.
Can you say that again?
I think the MMS was uploaded to a web server, publicly accessible web server, that I was able to fetch it through a laptop. Do you know anything about that?
I have no idea.
Okay.
Well, no idea about that. If anybody does know, please let him know. Any more questions?
All right. Great.
No questions?
Thank you for listening.
Okay, in that case, Ilya, thank you very much. Give it up. Well, enjoy your dinner and see you at 8:30 back here.